Chapter 5, describing numeric data. In this, we're going to go into the details of how do we describe numeric data. Numeric data could be how is our sales doing over the last 30 days. Let's say Amazon says, I want to find out how many units were sold and what was the average cost or average purchase price per unit. And so if they look at the 30 days of data, they'll probably create a histogram like this. Histogram is a really good way to describe numeric data. And a histogram with a box plot is even more informative. You know what box plot has? A box plot has this line, it's called a median, which is the 50th percentile. And then the starting is the 25th percentile or the lower quartile. The ending of the box is the upper quartile or the 75th percentile. So this box actually has total coverage of 50% of the data actually lies between this box. So it's a superimposition on top of the histogram. This is the histogram. And on top, you can have a box plot which says, hey, between these two data points, this is my 25th percentile, this is my 75th, and between these two I'll have 50% of the data will form between these. Meaning, if this was the number of units was, let's say, 1,000 here, and then if this was the cost per item was, let's say, $50, then what it's saying is, let's say this is 60, this is 70, this is 40, and let's say this is all broken down into 10 each. Then what it's saying is that between 70 and 20, 50% of my data set is covered. Now this is powerful. And if it is a symmetric curve, right, if you can fold it from the median on the left and the right, and you see the same symmetry for the most part. Most of the business data sets will be right skewed. You know why? Because dollar values or unit price can't be negative. So it starts with positive and then it can go have a long tail. And you can see that with the white space that you observe here. This white space is not just like that. If there's even one data point that the one high value money item was sold, then there's still going to be a white space. And so this white space tells you a lot. This white space tells you that, hey, there's a long tail distribution. Hey, there's a right skew, and most business data have it. But to understand whether you have a symmetric curve, you look at this data set and you can try to see if you can fold it in the mean and if it looks symmetric. There are tools to validate that as well, which we will get into. And Excel provides this statistics add-in where you can find all of this. You can create box plots, and there's a separate video that I'll create on how to use Excel to create all of these histograms from data and how to go about measuring this bell-shaped curve and where the data falls, right? So we looked at the box plot, and it typically has the lower quartile, the upper quartile, the median, and these are the whiskers. Whiskers are basically if you multiply the interquartile range, which is the lower quartile and the upper quartile, multiply by 1.5 times, then the whiskers are basically covering 1.5 times from the upper quartile, 1.5 times from the lower quartile. It's basically covering all of those data points. And there's hardly few that will remain after, but that will be plotted by these dots, right? So whiskers, if you have these 5 data points, which is the lowest point, the highest point, 25th, median, and upper quartile, then that's the 5-number summary, which is the minimum, 25th, or the lower quartile, C, which is the median, D, which is the upper quartile, and E is the maximum. And that's the 5-number summary, which can easily help you to create a box plot. Now, for a curve that is symmetric, unimodal, meaning it only has one mode, right? And you can see that there's only one mode. There could be graphs that can have like 2 modes, right? There's a mode here, there's a mode here as well, right? And that's because you've broken down the granularity. Even if you break down the granularity here, you probably see more of these modes. So what you do is you try to get the granularity such that you get one mode, right? So if you bring down this distribution, then if you lower the if you increase the granularity, it will change to this. Once you have a unimodal symmetric curve, then you can apply the empirical rule, and it's very powerful. Let's see what you can do with it. It says that if this was the mean, then within one standard deviation apart, 68% of the data points will be in that curve, right? So plus one standard deviation minus one standard deviation from the mean, 68% of the data points are going to be covered. And this is powerful because then you can say, hey, where is the majority of my concentration of my, of the business metric that I'm interested in? And then within two standard deviations, 95% of the data is covered. Within three, 99.7. So you can literally, get the full picture by looking at this bell curve, looking at empirical analysis to find out like where things are in your given, how healthy your product is, how healthy your sales are, by doing some of these analysis using numerical statistics. So let's look at some of the summary statistics that numerical data supports. The very first is the mean, right? It's the average. You can add all of these sales up, and you'll probably find out that the mean is somewhere here actually. So even though the median is here, the mean is here, because there's these sales that this one data point can probably eat up the weight of all of these data points because it's that high. So the mean is actually always going to be, when you have a right skewed data sample, it's always going to be on the right hand side of the median, because it's actually, mean is the balance point. You can think about mean as something that balances the two sides. If this was a total dollar value, then whatever you put here, the summation of all of the money here and summation of all the money here should be balanced. So the mean is that balancing function, whereas the median is the area function, right? Like what data point, and it's actually going to be here. You see the area here is much higher because there are more of these sales happening here. So mean balances your graph by weight. Median balances your graph by area, right? So median is going to be here. So we looked at mean, we looked at median. Median, again, we looked at even in the categorical data, it's the 50th percentile, right? Like if you arrange all of your sales and then you find the midpoint, that's the median. So mean is a good one, and it's very useful, especially you want to look at mean when you're looking at money. You don't want to look at median, because there could be one customer, like let's say Amazon has like one customer, let's say in Apple, and it's more important than maybe 100,000 other customers combined. So you want to look at dollar value and you want to look at mean as a statistic, not the median. Median is good if you want to find out like, hey, which product I should sell more, and you're trying to optimize for space and other things, then median is probably useful. S square is variance. This is simply for all your data points, how far away they are from the mean. It's basically given a data point, find out how far it is away from the mean, square it, and then keep doing that for all the data points. You will find the spread. S square variance is basically the spread. The higher the spread, higher the number, it means that the data points is just too far away from the mean. Right? And S is the square root of S square. It's a standard deviation. You can think about S is the measure of variability, and this is where this comes in. If you know that, hey, how is this product in this range doing, and if you find out that, hey, it's one standard deviation within, that means it's doing the similar function of all of our other products. But if you find out, hey, there's this product that is 3 standard deviations away from the mean, that means it has a high impact. If it's on the right side, that means that's something that's the customer you don't want to lose. If it's on the left side, you want to figure out what the hell's going on. Why is this not selling? It's just not productive. Similarly, this could also be, like we used that Amazon example, this could also be like the code reviews in your team. You could have ideally you would have a normal distribution. So if you plot out how many people are doing how many reviews, right? And then you can say, hey, how many reviews are being done? And if you find out that, hey, for a given person, they are like 2 standard deviations apart, that means you know that they're better than the 95% of all of your team members combined. That's powerful. But at the same time, if they are 2 standard deviations away from the mean on the left-hand side, that means they are at the top less than 5% of their productivity of the entire team. So if you want to find out how far off a person is in terms of code reviews, or how far off this product is in terms of the impact to my business, this numeric statistics is very helpful, because then you can find out like how far away are these from standard, how far away are these from normal. And so that's why it's also called normal distribution, bell-shaped unimodal curve. So again, mean, median, variance, standard deviations, very, very important. A way to standardize standard deviation is using coefficient of variation. CV is basically standard deviation upon the mean. It's basically saying what is the variation? if you pick a box of M&M chocolates, you'll probably have coefficient of variation 5%, or 0.05 will be the CV, which basically has only, if you pick any two random M&M candies, then the difference between them will be about 5%. So it's basically, coefficient of variation is measuring the percentage variation between two different data points, right? So if it is close to 0 CV, that means the variations, the measure of variation is very low. They're all similar. But if it's close to 1, that means it's not at all similar. So if you want to measure percentage variation, then you find out coefficient of variation. If you're trying to compare, let's say, M&M with Amazon, and if you want to find out how far off they are, then you can't compare them directly. So that's why you need a z-score. So M&M will have its own plot, Amazon sales will have its own plot, your code reviews would have its own plot, but then if you want to compare each one of them as to where is the higher variance, where is the measure of variability high, or where is it that it's varying much more, then you find out the z-score. Z-score is basically the distance of a given data point from the mean divided by standard deviation. What is the distance? So z-scores are comparable. So if you find a z-score of 0.1 of M&M, and if you find a z-score of 0.1 of Amazon, then you can say, hey, they are the same. They vary the same way. Same way, you can also compare z-score of Amazon stock with Microsoft stock. And then you can compare, hey, which stock is much more stable, or which stock actually varies a lot from the mean. And then you can find out what is your risk appetite, and you can use all of this in even stock markets and a whole host of other things. So that's the z-score. So we went into when you should use the mean versus median. Mean you should use when there is dollar value. And it's basically the split it's not the split in area, which is the median, it's the split that balances the weight of the graph, right? Remember, z-score also, last point, can only be used when you have a bell-shaped curve and you have a symmetric unimodal distribution. You can't do this for all types of bimodal distribution, or if you have a granularity that is not symmetric. So we learned quite a bit of the empirical rule, right, which tells you very quickly how far off you are you in the range, are you off of the range, how far off you're doing as a person in the team contributing code, as a product contributing to the business, as like visits to the website. Numeric statistics are very, very powerful, and histograms with box plot quartiles is very, very powerful to find out. We looked at how do we do this in Excel. I will create a separate video on how do we do all of this so that we don't have to calculate. It gives you mean, variance, standard deviation, coefficient of variance, z-score, and a whole host of other things. To briefly tell you, you go to add-ins in Excel tools, add-ins, and then do add descriptive statistics. And that's the package that you have to add in Excel to do all of this statistics in Excel. I will see you all in the next video. Thank you.